Okay, so here there's an annotate tools which allows you to see the distances, okay, between the two node points. This is 0.9 and this is about 1.3, right? So you can go in and check those and you can do a screen print of it, okay? Just so that if you wanted to copy it by distance, you can also do that, okay? So again, I'm just going to go in and edit, copy model, and then select the beams by fencing around. Let's say just 3 members. And then we can go in and select 2 joints again. And store that. And then we'll do the last one. So we can just say generate copy between the 2 node points and store that, okay? Okay, so now if you press X, Y, this will actually show you X, Y view in the graphics, okay? If you say I on the keyboard, it'll just show you an isometric view. Let's just go X, Y. And in this case, what I want to do is I want to copy by fencing again, and I want to copy all these T-posts that we have. And again, click on I to get an isometric view. I want to copy this from, let's say, this point to this point. Click on OK, and it'll just copy all the T-posts for you on to the other side, okay? Now again, go in, check your model, make sure you don't have any duplication of beams, any duplication of nodes. We do have, so I'm just going to delete those duplicate members, okay? So once you're done with that, you can go to 3D Solid and visualize if you have done your skid properly. If you hold the left mouse, right mouse button down, you can actually rotate, or you can zoom in to the skid structure that you have created in the past 15 minutes or so, okay? Okay, now GTStrudel has the ability to go in and figure out what the center of mass is going to be of this structure, okay? So here we can go in and go to let's say display. And here, first of all, we want to show you what the model statistics is. So we can see about 65 joints, 70 members, and 3 property groups. Okay, we haven't used all the 3 properties groups yet. Okay, so we can go to display, and here we can just say model statistics again. It'll actually show you the same options. But if you go to check model, okay, here there's options to say, hey, check the rigidity, body constant constraints, or you can just say weight and center of gravity. Okay, now here when you click on this button, it'll actually show you the center of gravity of this whole skid that we have modeled. Okay, now what I'm going to do is I'm going to create a joint only with the same coordinate, okay, so 3.152, that's in meters. Then I'm going to have it placed at, let's say, 3.5 meters above the skid, and let's say at z is equals to 0.4938. I'm just grabbing these global coordinates, center of gravity, except for the y, I'm just using 3.5. Okay, if I say store, what that'll do is it'll actually I'm just going to press enter to create that joint, and then click on store. So you see that joint is created in the graphics, okay, for you. Now what we could do is we can go to create, place members, and here we can draw those cables, okay? So we're going to take the bars elements, we're going to release the MY and MZ at both the start and the end nodes for these. And then I'm just going to say generate members, and what we'll do is we'll just connect the dots to where this skid needs to be attached. Okay, so here we can place one there, place one here, and then one here. And now this is the place where you would actually see if there's any interference between the members that you have drawn and the cables that you're trying to create. Okay, so here we don't see any significant interference. Okay, but if there is any interference, you might have to use a different type of cable system. Okay, now what I can do then is click on create, and next task is to create a support. Okay, so I'm just going to create a fixed support right there. Okay, but what I also expect is this thing is actually going to sway in one or the other direction horizontally. So I'm just going to restrain that by a very loose support, okay, along the X and the Z direction, because I don't want it to move along the X and the Z direction a lot. So I'm just going to say do not have any supports along the Y, MX, MY, and MZ direction. But I want to restrain the movement along the global X and the Z direction. I'm just going to create maybe a support there to restrain it. Okay, or we can just place it at the center. Okay. Anyways, let's just place it there. And once that's done, what I can do now is create a load. Okay, so if I go to create menu and click on loads and activate independent loading, let's just create our first load case and call it dead load. Okay, DL store, and in this dead load case, I'm just going to consider the self weight of the members in the global Y direction. Click on yes, create those loadings for you. Once that's done, we can analyze this structure. Okay, we can go to analyze, analysis, linear static stiffness analysis. If we go to stiffness standard analysis, okay, you shouldn't see any problems. Okay, so here we see there's no problems. The problem has been solved, and then we can look at the results like deformed shapes. Okay, so for the dead load, we can go in and animate deflection. So if we don't want it to shake so much, we can just say animation speed as 10, and then we can choose to have it deflect between the joints or no. Now that we have created this structure, we can just click on file, generate GT strudel input file, and it's a good idea to do this early on. And we can just say I want to save it as skid1.gti. What that does is it creates a text representation of your file on the hard drive. So if the computer was to crash or you had an outage, you still have this text input file somewhere on your machine. You can retrieve that information later on. Okay, so it's a good idea to back it off every now and then. Now let's go to redraw. This is the crane lifting type situation. Next thing that we want to do is look at some results. Okay, so if we go to results and let's go to joint reactions. First of all, you would see the joint reactions shown at the top. Okay, so these forces are shown to you in kilonewton. Okay, so we have 77 kilonewtons of force acting on this crane. Okay, first of all, you need to know if that crane can lift all this load. So this is the load that you can supply them with your factor of safety assigned to it. then you might want to see results like the force and moment distribution. So let's say we want to see the moment diagram just to make sense out of how the skid is going to have this moment because of self weight. Here is the bending moment diagram for the skid beams, okay? And you can go in and label those bending moment diagrams if you wish, and you can capture those and put it into your report. So for example, let's just use the snip tool to grab this nice picture of just the bending moment diagram. You just say edit copy and put it into my Word document, okay, that I can use later for my generation of my reports. Okay, now this can be done automatically also using the report builder. I'm just giving you some ideas. Okay, so if we go to, let's say, deform shapes, go legend and labels, and we can see what sort of deflections we have. So this is about in millimeters, so it's about yeah, that would be a lot of displacement. So if we want, we can change the unit system to meters. Then have it displace. I mean, this is displacing about 5 meters. Okay, so it's a lot of deflection, but we can constrain that by adding some supports so that it doesn't deflect that much. Okay, but anyways, this is not analysis results because we want to do a nonlinear analysis in which the cables act as tension only members. Okay,